Hi, good afternoon. We're going to talk today about automatic gearbox designs. We're going to talk about topic 15, which is this one. Okay, so what's a gearbox? A gearbox is mainly different type of gears, shafts, and synchro or synchronizers, which are inside the shaft and allow the whole system to move together to be able to transfer the power from an engine or from a power source to any other system on any type of machinery.
Alright, well now we're going to look at the background a little bit. We see the transmission. It was born when Alfred Horner Monroe in 1921, he made a transmission. It was ran on compressed steam instead of hydraulic fluid. Later on, years later, two Brazilian engineers integrated the hydraulic part of it, and General Motors bought the technology, later using it for tanks in World War II. So the first torque converter we see is the Buick Dynaflow in 1948. It's actually the birth of the modern transmission with our torque converter and the automatic transmission. The purpose of an automotive gearbox is simply, as Gianfranco put it, to convert the engine power into torque so we can move the car. Without a gearbox, the car would only use one gear, so you would have to choose whether it's second gear, third gear, or fourth gear, so you would have a really low start and then really high revolutions when you get to higher speeds. I put an example. For 80 miles an hour, if you wanted to top speed at 80 miles an hour, you would need a gear equivalent to a third gear in a manual transmission. So and also you need to compromise. You can't use a truck transmission in a compact car because transmissions are different. They're not all the same. Gear ratios. Every gear has a gear ratio. Every gear set has a gear ratio. The purpose is to lower the wear and to higher the fuel efficiency of the transmission. So as torque increases at higher rates, you see lower RPMs. So as you see torque get bigger and bigger as you shift gears, you see lower RPMs and bigger torque output. At high gears, usually we achieve approximately a 1:1 ratio. That's around 4th or 5th gear, depending on the transmission. And then you see an overdrive in the last gear, which is the 5th or 6th gear, depending on which the last gear is. The overdrive's purpose is that the output speed is faster than the input speed, and then you see a less than 1:1 ratio when you get to that gear.
So here we have a schematic of manual transmission. Here we have two different shafts. We have one called the input shaft and one called the output shaft. The input shafts come from the engine. Here you usually have a clutch. In this case we don't have it. We have the gears here. We have synchronizers and colors. We have forks, which come from they usually are for the driver to be able to select the gears. We have what else? We have the idle gear from when the transmission is not in gear, and this output shaft goes to the differential. Here we have current designs. In this picture we have standard straight cut gears. These are for high torque applications. We also have helical gears for low torque applications. We're going to go in detail why they use straight cut gears or helical gears. Here we have the three different tooth profiles. We have straight cut gears, which you can see here. We have high performance helical and OEM helical gears. The difference between helicals and straight cut are two main things. Helical gears are low price. I mean, they're not very expensive. That's why they use it on OEM. They are not very noisy. They don't produce a lot of noise. They are very efficient. They are like 99 to 98% of efficiency, which is almost perfect. And they offer a good torque handling depending on the application. Then we have straight cut gears, which are very noisy, but they are able to hold a lot of more torque than the helical gears. Here we have a picture of straight cut gears. The future for this kind of transmissions are basically sequential gearboxes, which are basically the same concept of straight cut gears, but the forks are being moved or changed by a shaft, which has different grooves, and those grooves allow for quicker shiftings. They hold a lot of more torque than their other parts of helical gears, and it's easier to get into gear because they use, instead of using the simple color or synchronizers, they use colors with dogs. So they call it dogs. So it's called also dog engagement transmission. Here we have design we did on SolidWorks. There are different gears. Basically, they're not as much gears as a car, but it's basically the same principle. Everybody's looking, or when they are designing something, to have a very high efficiency. In this case, we can achieve that because it's quite simple. There is not too much things to change because the design of a gear is pretty much stable today, so there is nothing aside from that. The torque handling is also important, but it will depend on the type of gears. Since helical gears, they transfer axial load, and straight cut gears, they usually just transfer vertical load. And the axial load transfer for the helical gears usually damage the shafts or the cases. So when using high torque applications, you will need to have a very strong case and shaft. So that's why people, users go with straight cut gears, so you don't have the axial load. Here's the SolidWorks design.
The automatic gearbox is another type of transmission that different to the manual because doesn't need any physical movement from the operator to change the gear shift to the desired ratio gear depending on the vehicle necessity. And the main part of this transmission we can come in the planetary gear, also the torque converter, clutch pack, and hydraulic system. The planetary gear is one of the most important parts because consists in one main small sound gear, as you see on the picture, which is surrounded by a few satellite gears that is spinning at the same velocity at the same time, because the planet carrier that fix all the gears in the same length. Finally, we have the ring gear, which is the biggest one that encloses the whole system. Next, we have another important part, which is the torque converter. This is the one that is in charge to change, to receive the mechanical energy or mechanical movement from the engine. This one converts this energy to the transmission. So the main part that we have the turbine, the starter, and the impeller. And the impeller is one of the pieces that is connected to the shaft, and it also has a set of curving blade full of fluid. So as soon as the shaft from the engine rotate, it produces a centrifugal force that direct the fluid outside from the middle of the shaft to outside. So the housing direct the fluid through the turbine and the starter. So in that way, it receives the mechanical movement and transfer to the transmission. So then we have the clutch pack, which is a set of discs that are made for metal and friction plates. Those are named friction plate because it's composed by carbon fibers that when it's pressed they are assembly in a pack, placed in the housing clutch, like you see over there. So the system contains a piston that can break or release the main shaft. Lastly, we have the hydraulic system. As you can see, the hydraulic fluid, hydraulic pressure is very important on this system because the torque converter, the clutch, and also for hydraulic purpose, they need a very efficient hydraulic system. So the presence of the pump, a mechanical, electrical pump, is in the most of the new cars. So it can take, as you see on the pan of the transmission, it can take the oil make sure that all the parts are in a constant pressure, high pressure.
So, okay, we're going to talk a little bit about the transmission case. Well, this is where the actual transmission is inside of the engine. It protects, the case protects it from any particles that are foreign to the engine, any particles from the street or anything. If some rock hits it, it would hit the case, it wouldn't hit the gears. So it would be, and it gives the mounting points for the shafts and all that stuff. Okay, we got seals. Transmission seals are very important because it doesn't let any metal touch another metal, so it gives everything its place and its clearance. It gives oil clearance to the parts where it needs oil clearance. We can see bushings, O-rings, metal clad seals. We can see the oil pan gasket right here, and some a bonded piston over there. And it also takes the bushings that separate the shafts from the actual gears. In conclusion, you have to make, when designing a gearbox or a transmission, you have to make it robust so it lasts, and very accurate designs, obviously, because these are very small mechanical parts that have to last a long time for our clients. And automatic transmissions are probably going to be the future. They're going to be more. We see more gears coming into the market, and yeah, I mean, just use responsible engineering when designing this stuff, and just do a good job. Thank you very much.